to join. All right, I'll kick off with the introduction. So welcome everyone to day 3 of the Understanding Latency webinar series. My name is Björn Everteigen. I'm head of research at Domus, and I will be your host. So first, practical details. We'll have 3 types of sessions during the webinar. Today kicks off with a keynote talk, followed by a series of panel discussions and talks. Panel discussions will be roughly half an hour, and each talk is 15 minutes. After each session, there will be a Q&A, so we invite everyone to ask questions. To ask a question, please use the built-in Q&A functionality in Zoom. Questions can be asked at any time, so you can just submit the questions as they come to mind, and we'll take them after the talk is finished. And if you submit questions in the chat, we'll try to get to those as well, but it's much harder to sort of organize and keep track of those. So if you want to maximize the chance that we get to your question, please use the Q&A functionality. So on Monday, we covered what latency is and why it matters. So we had discussions about the causes of latency, how it affects application outcomes, and this talk will be made available on video to everyone who's registered, and it will also be posted on the website. Same goes for yesterday's talk, where we covered how big the latency problem is and what is being done to fix it. So yesterday we heard from people working on large-scale measurements, measurement tools, or solutions that improve latency in the internet. Now, this will be a knowledge-sharing event. The point is to share experience, insights, and best practices related to measuring and improving latency. So this is about highlighting a problem space or an opportunity space that all of us have a shared interest in tackling in the best way possible. So with that in mind, I'd like to introduce today's program. Today's theme is commercialization and deployment of low latency solutions. So we have speakers talking about how solutions can be deployed, what the challenges arise when trying to do that kind of thing. And we have a keynote and one panel before a 10-minute break. And then after the break, we have another panel and one more talk before the closing remarks. So with that, I'd like to introduce our first keynote speaker, Stuart Cheshire from Apple. Stuart is Apple's distinguished engineer for networking, and he has been fighting latency both in end systems and in the network itself for many years. He's the creator of Bonjour, which is Apple's service discovery protocol. He wrote Bolo, which is one of the earliest internet multiplayer games, and he's the author of It's the Latency Stupid. So Stuart, please, the stage is yours. I will stop sharing so you can bring yours up. And please, other panelists, if you can turn off your video so as not to distract from the talk. That's much appreciated. Thank you. We cannot hear you yet. There we are. Now we can hear you. And see your screen.
Great, thank you. Hello, everybody. Let's get started. We've talked a lot the last couple of days about delays in the network, and I want to quickly recap where those delays come from. We've talked about serialization time and various other sources of delay. Serialization time shrinks as bandwidth goes up. One of the reasons that more bandwidth is nice, even though it's not the whole solution. Propagation time is basically the speed of light. And we're well aware of that. That's why we put data centers in big geographic centers close to the consumer. Processing time shrinks as CPUs get faster. There are other overheads like access to the Wi-Fi channel, and work is going on there. But I think we all know in today's world, the elephant in the room, by far the biggest delay is the queuing delay. And I want to recap something we've talked about the last couple of days, because I want to make sure this message is really, really clear to everybody. When the internet community rolled out IPv6, it took decades, because to really be useful, every component in the network had to be upgraded to support IPv6, and that takes a long time. The really key insight here is that's not needed to fix buffer bloat. We don't have to fix every hop on the path. On any given path from sender to receiver, there is one link. That packet might traverse 10, 20, 30 hops through the internet, but one of those will be the link with the lowest rate. And that rate obviously defines the upper bound for the whole end-to-end path. And the sender doesn't know in advance what that rate will be, which is why we have congestion control algorithms. But as the sender hunts to explore the right rate, when it goes over the bottleneck rate, that's when the queue starts to build up, and it builds up on entry to that bottleneck link. There may be other hardware on the path that has got badly designed queues with buffer bloat, but they don't matter because that's not where the queue is building up. So the key insight here is if you identify for a particular user where their bottleneck is, like for me, in the upstream direction, it's my cable modem at 35 megabits per second. In the downstream direction, it's my Wi-Fi access point. By fixing those two queuing algorithms at those two places, I dramatically transform my internet experience. And we want to get everything fixed, but it's really important to understand that in order to see an immediate benefit, you only have to fix the one hop that matters in the network. But there is one other queue that also matters, and that is actually in the operating system of the sending server itself. And that's because an application can generate data typically at a very large rate, too large for the network to carry. And the job of the congestion control algorithm is to meter that data out onto the network at the right rate. And just like in the network, application writers and people developing operating system software, it's very easy to have the attitude that RAM is cheap, and if some buffers are good, then bigger buffers must be better. And we discovered this when we were doing some work at Apple, and the mandate we were given by our management is we want the user experience to be much more snappy. We want the user to be able to jump to a different video or jump to a different place in the same video in under 1 second. And we set out to achieve that. We had a network with buffer bloat fixed, so that shouldn't be a problem. The video streaming client was optimized, and yet still switching video took a long time. and I can demonstrate that. I talked earlier on Monday about the network quality test in macOS. By default, that talks to servers that are run by Apple. But if you look at the instructions provided here at GitHub on the network quality server project, there's a configuration package that tells you how to set up your server to host the right files for the network quality tool to get and put in order to do its measurements. So for the network operators in this meeting, your task is to fix buffer bloat in your network. But if there are any content providers looking to improve their customer experience, you can actually test your own server to see if there's hidden buffering inside the server. And we did this. And when we hit that server, we see it has terrible RPM. It's only getting 90 round trips per minute. And this video server is serving video content of old Apple Developer Conference presentations. And when I play this video, I'm watching this, I want to skip ahead somewhere else in the video. And it's buffering, and it's buffering, and it's buffering, and there we go, the video is playing again. We're also used to this experience that we don't even think twice about it. We know that when we skip ahead in a video or we watch a different video, we're going to have to wait for it to rebuffer. And we didn't accept that as inevitable. And we looked into how can this be so slow? We've got a gigabit network, we've got gigahertz processors, we've got lots of RAM. How can it take multiple seconds to be doing these things? And when we investigated, we found that in the kernel, the TCP socket send buffer was set to 4 megabytes. The TLS buffer was set to 256 kilobytes. And the HTTP server itself had another 4 megabytes of buffering. So we had 8.25 megabytes of data queued up. And what that means is that when I'm watching a video, the HTTP server is serving my client's GET requests and filling up a backlog of 8.25 megabytes of data. And that could be several seconds worth of video data. And when I click somewhere else, suddenly I don't care about that data anymore. I don't want to watch that. I want to watch something else. But it's too late to claw it back from these queues. We did think about designing APIs that let you tell the kernel, you know, that data I gave you to send, forget about it, give it back. Turns out that's really complicated. It's much simpler just not to overcommit the data in the first place, instead of to send too much and then try to pull it back. So we cut the web server buffer down to 1/4 megabyte, we cut TLS down to 32K, and we cut the TCP send buffer down to 128 kilobytes. And you can do this yourself on your own servers very easily. Here is an example of the configuration for Apache traffic server. For other web servers, check the documentation for how you adjust those buffer sizes. And now, with this simple change on the server, when I play a video, first we checked the responsiveness, and yes, the responsiveness tool is showing that we're getting much better responsiveness. So let's see how that's reflected when we play a video. We're playing the video, we skip ahead, and instantly we're seeing the new content. I'll tell you, when you get used to this, it makes it very hard to go back to slow, sluggish networks. So we found some interesting results here. And this is using the TCP not send low watermark option to limit overbuffering in the kernel and the other changes at the TLS and web server layer. In addition to giving really snappy user experience for random access, we actually saved a whole bunch of RAM on the server, because when you've got a server serving thousands and thousands of clients, those 8 megabyte per client buffers start to add up to quite a lot of RAM. The other interesting thing is we got a measurable reduction in the video stall rate. Because if you think about it, most streaming video is adaptive. It will adjust to your network conditions. And if for some reason your network slows down, maybe somebody else is downloading a file and now you're sharing the bandwidth, the rate has to adjust. And when the client says, I can't take that rate anymore, please drop to a lower video quality, that's like the human skipping ahead in the video. The client no longer wants the old high rate 4K video. It wants a slightly lower rate video. And if there's a huge backlog of old data, that delays how agile the rate adaptation can be. And by making the rate adaptation more agile, we actually produce quite dramatic reductions in the video stall rate as well. So we improved the user experience, we saved RAM, and we made random access really snappy. So that's my message for all the content providers in this meeting. Take a look at your servers, because there are opportunities there for improving responsiveness too. Thank you.
Thank you very much, Stuart. That's super interesting. We will be moving to the Q&A. So I have a question actually, and that is, this is something that's deployed on Apple devices today, right?
What I'm talking about now is server-side configuration. So let me think about your question. Yes, on the sending side, if you're writing an iOS app that is sending large amounts of data, then these default configuration options are done for you. If you are running a service in the cloud or in a data center running on Linux, then that's obviously not a product that Apple produces. So tuning those parameters is up to you if you're running a Linux server, which most internet services today are built on Linux.
Right. And we have other question as well. Why are those server-side configurations not optimized by default on other providers?
That is an excellent question, and that's why this webinar is so essential. We need to get the message out. It's as simple as that. For decades across the whole industry, people have looked at throughput numbers and not paid that much attention to latency. And if you're not looking at latency, bigger buffers seem better. You make the buffer 10 times bigger, you might get 1% more throughput. And in a market that's desperately competitive for throughput numbers, 10 times more buffering is the price you're willing to pay for 1% improvement in throughput. It's only when you start looking at the cost of that buffering that you realize that that is a horrible trade-off. So I think if we ask this question again in a year or two's time, the answer will be very different. I'm hoping that everybody will have got the message by then. But at this point in time, this aspect of server performance is something that's not widely known.
All right. Great answer. We have another question as well. Shouldn't TCP small queues auto-tune the operating system buffer in Linux? And perhaps you can explain what TCP small queues is to those that don't know what that is.
I'll confess, I've heard about that. I'm not an expert on it. There might be one of our other panelists who could probably give a better description than I can. I'll answer that as best I can. So at one level, whatever buffering you've got configured at your web server layer is obviously purely at the application layer. So that's out of control of the kernel. Likewise for the TLS library. The key insight for the transport protocol is, and I kind of glossed over this in my presentation in the interest of keeping it short. In order to get good throughput, you need enough data in flight to fill the bandwidth delay product of the path. So if you just sent one packet and wait for the ACK, that would be the ultimate short queue, but you'd get terrible throughput because you'd be limited to one packet per round trip. So any sophisticated transport protocol has a window flow control where you have multiple packets in flight. So you have a stream of packets going out, you have a stream of packets coming back. You want just enough to fill that round trip. Any excess that you build up just becomes delay with packets sitting in memory that haven't even left the server yet. And this is where the TCP not sent low watermark socket option becomes critical, because the TCP send buffer option just sets the total size of that buffer, which is the in-flight data plus the backlog that's waiting, and it conflates those two measures. The TCP not sent low watermark option decouples those. So you can set your socket send buffer to 4 megabytes in order to ensure that you can have enough data in flight. But the TCP not sent low watermark tells the kernel, just because you got 4 megabytes, don't fill it all the way up. Use what you need to keep the pipe efficient. But once you start building up a backlog beyond that, immediately stop asking the application to provide more data. And I believe TCP small queues has a similar flavor to that, but maybe somebody else can clarify exactly if that does the same thing or something similar.
Thanks. And I think this will be the final question. Is there a published best current practice document that addresses this specific buffering guidance for server-side folks?
The best answer I can give to that, it's the link I showed at the GitHub repo. That is our guidance. I'm hoping that the industry will continue to look at this and develop a consensus. So that's it's worth mentioning this again. On GitHub, there's a project called Network-Quality, and that's not just Apple stuff. There's actually a growing community of people working on network quality, contributing to that repo. There are client implementations there. There are internet drafts live in that repo, and the instructions for our recommendations how to configure your server are also available there. So I encourage everybody to check out the network quality project on GitHub.
Excellent. All right. Thank you very much, Stuart, for the keynote talk. And we will move to the panel discussion. So our next session is a panel on commercializing low latency solutions with Gino Dion, Magnus Olden, and Angus Laurie-Pyle. Am I saying that correctly, Angus?
Yeah, you are, Bill. Thank you.
Thank you very much. All right, so Gino is head of innovation at Nokia and has been leading Nokia's work on implementing and commercializing several low latency technologies such as Pi Squared and L4S. Magnus Olden is CTO of a latency management company and one of the co-authors of the Quality of Outcome Internet Draft. And Angus is a technical lead at GameBench, where he specializes in collecting and analyzing key gamer metrics with a focus on latency. He has 15 years experience designing and implementing low latency game engines and is a keen gamer himself. So with that, let's start off with, I think we'll just start with a hard question. So to what extent are consumers willing to pay for lower and more consistent latency in their networks?
Well,
Who wants to go first?
I might go first. They absolutely are. And there's a lot of proof points behind that. And I'll tell you a couple. The first one is there isn't a week that goes by that I don't have a carrier from around the world, tier 1, tier 2, that doesn't call asking, how can I monetize this? And when I say this, I mean latency, working from home, gaming, better experience. I love what Stuart was saying, and I love some of the other things that came up during the panels with Dave that I see very active in the chat and everything else. The reality is we live in a multi-gigabit broadband world, but we're still sitting here watching spinning icons. And so the reality is there's definitely a willingness to pay. And I've did my own surveys. Now I took the time during webinars such as this one to interview hundreds of people, if not thousands. And my numbers came to about 80% of the consumer base is willing to pay a certain amount. What is that certain amount? Anywhere between $5 and $20 for a better experience. It just so happens that Omdia released a paper last year where they surveyed 10,000 people, and they found the exact same thing. Nearly 80% of the respondents are willing to pay for better quality of service experience. When you look at the new generation, my 20-year-old daughter, she's never gone through the dial-up days. She's never gone through the DSL and the DOCSIS and 5, 10 megabits. All she's ever known is broadband. And they look and equate things differently. They look for different things. They buy and consume broadband in a different way. For them, it's about the quality of service experience. Who has the best Wi-Fi? Who has the best Meta experience? Who has the best Instagram experience? So they're absolutely willing to pay for that. No, we have to move beyond the bandwidth on that one.
Yeah, I think there are plenty of good points there to just keep going on. And yeah, we've also seen, we've done plenty of research with ISPs and seen the same thing, right? There is willingness to pay, at least on paper. And we know there are low latency solutions out there that people are paying for. But I think the core challenge that we're facing is quantifying what does quality of service mean, right? Because 20% lower latency, or even more complicated, like 50% lower latency under load, like what does that mean? So I think there is a great deal of education that is still needed before this can kind of become larger scale, right? More mass market. And yeah, I think that will be the key to kind of get the ball rolling, to see whether people are certainly willing to pay for better quality. We know that because people are willing to pay for higher bandwidth. But what do we see now is that, even you see service providers in the US and in Europe have started in their commercial and not talk about bandwidth at all, right? It's not even mentioned, right? So kind of even what's going out to consumers is starting to change in how we communicate and how we talk to them. So the ball is rolling, and I think it will roll even further very soon.
Yeah, I'd just like to add from obviously we do a lot of gaming based benchmarking, and there's always been, in the gaming community, there's always been knowledge of lag or latency, and reduced lag is better. And that's been a sort of an understanding for a long time. But it's about trying to educate the general population about how it can benefit other use cases. For example, just surf the internet, loading a web page. Latency in some aspects can have a bigger impact than having a big 1 gigabit connection. So I think there's some education involved, or quite a lot of education needed. But I think we're starting that journey now.
Well, I actually blame us, the tech guys, for not having been able to make the proper translation between the benefits. Because yeah, you see a lot of carriers saying we have the best gaming network, the lowest lag, and whatnot, but we've yet to translate that into something that the consumer can put a value on. If you're a gamer, and I'm a big gamer, I'm sure you are, Angus, as well, and whatnot. If somebody comes to me and they do, Bell Labs will say, hey, we made this improvement to our pi-square algorithm and improves latency by 20%. I'm like, awesome. How is that going to improve my FPS? How's it going to help my kill death ratio over the next season of Apex Legends? And they look at me with blinking eyes. I'm like, how do you expect the carriers to sell this if you can't translate it into the value that the intended audience? Just saying lower lag, okay, great, but that I can't put a dollar amount. If you tell me that's going to increase my kill death ratio by 2 points over the next season, the next quarter, you know what? I'm willing to pay $10 for that over the next couple of months. I'm willing to pay $20 for that. So we still have a way on the commercial side to translate all of the beautiful things we do in the background into what's really important to the intended audience. And I challenge back a lot of carriers, because they'll say, well, on paper, like Magnus, you said, on paper it looks good, but are people really willing to do it? And some carriers said, well, we tried that in the past. I said, you tried it and you failed because you didn't really provide the real value. You weren't able to explain it. You weren't able to qualify it and quantify it. And that's why you failed. It wasn't because people aren't willing to pay for it. You were just bad at it. And, you know, it makes for interesting conversation, but that's just the honest truth.
Yeah, and I think like 5G kind of did us both a favor and a disadvantage, gave us a disadvantage, because 5G even to end consumers, right? I seen like Norwegian incumbent had a commercial. It's like, oh, 5G, it's lower latency, and like, what does that mean? They didn't quantify it at all. They just say, hey, it's lower latency, and I feel that that's been like a something that's, you know, gone through all the like low latency commercial offers I've seen. It's like, it's low latency, but you know, anyone could say that in a sense. Like, I'm sure Angus has measured low latency solutions before to find that they actually are not that low latency. And again, like, it's quantified for what, right? Back to what you talked about a couple of days ago. It's like, it's just low latency. What does it mean, right? So you need to be
Well,
better
it's funny. I see one of the mentions in the chat by Owen that, you know, competitive leagues will do latency normalization, and that's absolutely true. So I work with a lot of the gaming studios and talk to them and the developers, and they have to. So they implement a lot of tricks behind the covers at the server layer, at the client layer, to be able to normalize latency. But you know what's funny is, as a gamer, I was actually able to prove that if you're on a very low latency network, this normalization can actually work against you, because it favors the people that have a higher latency in a lot more favorable. So if you're on a low latency network that is not very consistent, you will actually be put at disadvantage against the players that have a higher latency, but more consistent latency. So it's really interesting to see what they do on their side to be able to provide a better gameplay, fighting against the network and the network fighting back again. So there's a lot of these weird idiosyncrasies that start happening that, you know, one impact the other, because they're all trying to solve the same thing independently, unfortunately.
And like the consistency of latency has been a theme throughout this webinar series, right? And kind of the people who are on this webinar series understand it, but you know, that's even more challenging to communicate to end users, right? And we could take it even further. It's not even how much it varies, it's also kind of how it distributes, right? For some games, a high 99 percentile is worse than the high average, and for some it's the raw variation, raw jitter metric that matters the most, right? So it's really challenging. And I think to be able to successfully commercialize it, and even it doesn't have to be monetized, but even just getting a competitive edge, right? Because I think that's what everyone here wants, right? We want service providers or any network operators start competing on latency, right? If they did that, like, everything will be solved very quickly. And
well,
yeah.
you know, one example that I like using around why it's important when I explain this to carriers is, if you look at 15 years ago in our laptops that we all had these nice spinning mechanical drives, you know, 7,200 RPM, whatever. And you know, you open the file, it would take 5-10 seconds, you know, whatever it is. Then we went to SSD drives, and it's blazing fast. It was great and whatnot. Now we've moved on to cloud-based drive, you know, OneDrive and things like that. People don't realize, if you open a drive in one file, or a file in OneDrive, you're making, you know, dozens of TCP requests, authentication, metadata, the actual file descriptors, blah, blah, blah. I'm back to the same speeds of my mechanical drive, just because of latency. Going, you know, from 1 gig to 8 gig symmetrical broadband is not going to make my OneDrive any faster. It's not a throughput issue. It's that round trip, in which I love what Stuart and Apple have done with the RPM concept, because that is literally a measure of what the experience will be. But in terms of the commercialization, what I see a lot of the questions coming up, one of the things that carriers often fail to forget is there's a huge potential for enterprise services in a residential context. You know, we have a lot of people working from home. We have a lot of these things, and the enterprises are willing to pay for a working from home experience that is equivalent as if you were in the office, for productivity reasons and all these things, for security, productivity, and whatnot. And we've done trials, Magnus, that we're able to prove that. But I think that's one of the angles that people seem to forget, is even in a residential context, there is a space to sell latency-based management to enterprises because of that.
I just wanted to, as I'm watching the chat go up, I think it was Dave, I've actually lost the comment now. I don't want to talk about gaming for the whole panel. I want to leave gaming where it is, but you made an interesting comment about cloud gaming, which is something that we've been looking heavily at. And yeah, I think the future is actually, even though Stadia has gone the way they go, that cloud gaming has a really strong presence in the future, because I don't know if many people know this, but with some of the service providers of cloud gaming, you get a better experience, you get better latency than you do with a current generation console, which is mind-blowing in my head, if you have a good network. And that resolves your latency issues that you'd have with multiple players. They would all have the same latency, or similar latency. It resolves issues of cheating, or many of the issues of cheating, because you don't control the client at all. And I think we'll see more real-time services like that, because that really does push it. That's quite, when you're pushing 1440p videos at 120 frames a second, that's quite a high bit rate, but also really low latency. I think that starts showing that we can do things like in the future doing XR, virtual reality or mixed reality or augmented reality, which is, I think, something that's going to need to be done on remote rendered servers, because you're not going to have the compute power on a pair of glasses or on a contact lens, and that's where I see the excitement coming from. But it does require, and this is another thing I want to lead on to, is the 5G. Sorry, Gino. The 5G networks. And yeah, there has been a lot of advertising on 5G networks that I think has given a bad representation of 5G. And a lot of people don't really realize that 5G is a massive bunch of technologies, really. And I think those are the areas that we would see a lot of improvement people would be quite interested in the future when new services come out. Video conferencing is one. Video conferencing has made massive advancements certainly over the COVID period. So the last 5 years, video conferencing can be used very reliably now, wherever you are. And that's something that people would, I would certainly pay for my day-to-day life.
Well, you're absolutely right, Angus. The thing about 5G, and full disclosure, being from Nokia, we are a big 5G company, but the reality is, does it have the potential to provide better latency? Yes. Does it today? No. I would argue that LTE Advanced will provide you the same throughput latency that most 5G, put millimeter wave aside, can. If you look at the technical specification, yeah, you can do ultra reliable, low latency 5G. But that's meant to be used in an industrial context. It's never going to be used on a mobility type service because of the tax that you get for the reservation of the spectrum and the throughput. That could never fly. There's just not enough spectrum to be able to do that at scale. So 5G does have a lot of tricks up its sleeve. I think it's up to the carriers to be able to find ways to be able to take advantage of that. So does it deliver today? No. First one to admit. Does it have the potential? Absolutely. I think there's some very interesting things that we're doing that will showcase some of that in the next couple of years. But today, you're right. It's been a little bit lackluster on that side.
And that's a key point for commercialization. Right? We need a few good use cases, right? Video conferencing and gaming is kind of driven, at least the broadband providers I work with, to look at latency solutions, right? But we know they are mostly very financially driven, right? So they need to see, okay, if I make this investment, I invest in the software that makes me put AQMs on all routers or L4S or low latency DOCSIS or whatever solution it is, right? They need to see that there is something to make from it, right? This is mostly true for all major ISPs. So I think the key thing is that we need to be able to make that more commercially viable. We need to be able to help ISPs and network operators in general get a competitive advantage of bringing these low latency solutions into production and deployments, right? Because a lot of them exist, and yeah, I'm Dave and Tulke and all can just talk for days about all the solution that exists but is not deployed, right? So I hope we can move forward on that part.
Yeah, what does it take for ISPs to be able to do that, to commercialize these low latency solutions and show that there's a financial return on it?
I still say it's sorry, go ahead, Angus. I didn't want to cut you off there.
I'd probably say the same thing. Well, from my point of view, it's education to the end user, what low latency means and what it will provide them, as opposed to, so we've got away with a long time saying 56 kilobytes per second, megabit per second, megabits, sorry, per second, 50 megabits, 100 megabits, a gigabit. It's all bigger numbers, means you get better experience, and people have been very much sold on that since the birth of the internet, really. And now we're shifting to understanding actually we've got enough bandwidth now. Latency is the issue, and I feel we, from the technology side of things, we need to start helping ISPs to educate end users what low latency will actually mean in real life. Will it mean faster web page experience, just surfing the web? Yes, is the short answer, I guess. Oh, there's a lot more complicated answer to that, I guess. But the gaming is the obvious one, the one everyone goes to, but just something as simple as surfing the web would be improved with a far better latency infrastructure.
Yeah, but you all agreed that customers are willing to pay for this, so why aren't any ISPs sort of offering these kinds of plans? There
are service providers that are offering some gaming solutions that kind of prioritize gaming and even routers with more advanced AQMs. The thing is, like, they're still very bad at selling them because they say low latency. I mean,
what does that mean to the gamer? Correct. So this is why I kept going. Like I kept going back. This is our fault. We need to translate that into, show me concrete results that will show this will give me a guarantee of 55 frames per second over 6 hours of gaming. This is going to give me, like I said, a better kill death ratio over the next 6 months. I can improve it by 2 points. These are the things that the end user understands and is willing to pay. And I'll admit, it's not easy. I mean, we do our own work, we do our own studies to be able to showcase that. But that's where we need to be for the carrier to feel comfortable. And at Nokia, it's weird because I sit in the middle. I see all the cool technology, I see all the cool potential, and I'm like a schizophrenic. I got the carrier saying, well, I want to do this, but I don't know if I can sell it. And my business units are like, well, we don't want to invest in the engineering because they're not asking for it in the RFPs. So, I got to pull on both sides to try and get everybody together to be able to bring that. But like I said, I don't blame the consumers. I don't necessarily blame the carriers. I blame a lot of the techies, us, for focusing a lot on the cool aspects of the algorithms, the technology, all those projects. But at the end of the day, if we can't put it in layman's terms, the people that have the money and are willing to spend it, well, they're just not going to ask for it.
And I think, by the way, the best thing that is happening for this is Ookla adding latency under load. And when they will start sharing the reports of latency under load for service provider, I think things will move a lot faster, right? And what really we should do, and everyone who knows a gamer, is just go and point at that number, and we'll go and punch Ookla and make them make that number a bit bigger as well.
Well, the latency under load has been the dirty little secret of everything. It used to be that if you were the best gaming ISPs because you had the best throughput, which is far from reality. We did a project last year with a tier 1 carrier that called up and it said, no, we have the best fiber network in North America and maybe the world. how come we're never the best gaming ISP? And at the end of the day, when we finished the program with them, what they realized is, yeah, they had lower latency than any other competition in their national market. They also had the most inconsistent latency, which killed cloud gaming, which killed everything else. So for them, it was like, we focused so much on the low latency as a, almost as a speed test. Hey, I can do a ping with this, not really understanding if you have it under load in real life situations. Have you actually spent time with real gamers? People that do this for a living on Twitch, people that can actually convey what that really means to them. Then they realize, crap. So, it's not just about low latency. It's about providing, the CDF curves are crucial in explaining, these kinds of things. How does it look like at 99 percentile, 9.995, and so forth and so forth. This is really what's key to providing and being able to sell this both in a residential and enterprise context, is being able to qualify it that way.
Do you think it needs to be sort of a part of the plan that the ISP is selling, like that it's sort of a latency guarantee? Can we even deliver on that, or is it just about sort of making a better product without
It's
actually
making the better
promising lower
product.
latency, but just delivering it?
I because there's so many moving parts, I think going down the SLA road is impractical. I mean, it's something that looks good on paper, but I think from a commercial point of view, it's probably not practical today. That being said, they absolutely can provide a service that can be qualified and quantified as better. Can you guarantee that it will always be that? No. I mean, your neighbor can start a microwave and you have zero control over that Wi-Fi access at that point, and so forth. But yeah, I think the carriers can, in fact, and must move away from bandwidth-based tiers to a more a la carte experience. Like I gave you the example on my daughter. She's never known anything but broadband. She doesn't care if it's 100 meg or 1 gig. I mean, I get calls and people, carriers from all around the world that say, oh, we're launching XGS PON 10 gig. We're launching 25 G PON. What's the killer use case? There is none. Focus on latency. If you want to sell 25 gig, focus on latency, focus on your packages and what you can deliver. There isn't a single service on the internet where you could come anywhere near besides the speed test bragging right. That's the only thing that kind of bandwidth was going to give you.
Yeah. All right. We are a bit early for questions actually, but there are so many questions, so I think we'll just jump right to those. So the first question is, can you comment low latency on certain flows versus all flows? Some AQM techniques prioritize flows, for instance, via DSCP, and will realize low latency only on those flows. Is that okay to customers?
That's an interesting question. So DSCP is something that carriers have been using forever in the core network, but they always sanitize anything coming from the home because they don't want the end user to be able to override what we're doing in the network. So DSCP is great inside the network, but at the ingest of the network, it's usually sanitized. It's not honored. I think what's going to change that is all of the great talks you guys have added with L4S, which for the first time, we have a protocol that the application network can share, can communicate with each other, and can provide some level of fairness. So yeah, DSCP is great in many situations, but I think we have to evolve beyond that if we're and L4S is probably one of the good alternatives that we have out there that can deliver that.
On the flip side of that, we are seeing several service providers who want some way to have a differentiating feature for their customer. And one of the ways some of them are looking at is, hey, can people prioritize different types of traffic within their household, right? And using that as a key feature to differentiate stand out from the competition, right? Which is kind of a good way of getting the foot in the door for low latency solution without necessarily being the end goal, right? So, from a product standpoint, from a broadband provider, maybe that's a good way forward. All
right, thank you. So beyond gaming, what other use cases where this value proposition can be demonstrated and sold?
Oh,
Examples.
there's many. I mean, gaming is the obvious one that comes to mind because it's such a huge industry and there's so much money behind it. But the whole working from home, the whole education, the whole enterprise services in a residential context as well. You know, on these 10 gig pipes to the home, there is the ability to slice and carve that out to offer other types of latency-based sensitive services that an enterprise is willing to pay on top of that pipe, either to get access, you know, appliances in a home, the automotive industry that could connect to your residential broadband, take advantage of that with certain latency requirements. So and there's probably half a dozen other types of use cases that we're looking at. So yeah, there's many more. If you look at the education system, you're looking at the enterprise. If you're looking at the gaming, even the healthcare, for remote healthcare, we're doing some stuff with that as well, which is quite interesting. Even, I'm not saying I'm a huge fan of it personally, but even in the online betting, being able to provide the quickest and easiest access to scores and results, and even online poker and things like that. There are services that enterprises are willing to pay to get access to better latency on residential broadband. So it's not just about what you sell to the end user in the home, is what kind of services can you sell that are latency based to enterprises that want access to that user in the home. So there's a lot of different ways that this can be monetized. So it's not just about nickel and diming the consumer. It's also, there's a lot of people that are willing to, there's a lot of different types of enterprises that are willing to pay for access to these kind of capabilities.
Don't forget financial markets. They
Absolutely.
spend quite a scary amount of money on trying to reduce latency, using their own networks, putting dishes on top of the shard. So there are all sorts of areas where latency, when you're talking about money, there's many opportunities to sell better products.
I see a question from Dave, and I love Dave, so I want to give him a second there on.
Go ahead.
Yeah, so on the published latency, Davey, if you send me an email, I'll be happy to share some stuff. But the reality is, if you look at a traditional GPON network, 1 gig, I'm not even going to touch XGS or 25 gig. You have 8 time slots per second, so you can literally go down to a transmission slot every 125 microseconds. That's how low of a latency you can do. Now, do most carriers for residential broadband configure that way? Absolutely not. So you'll typically see between 1 and 3 milliseconds. So it's a configurable thing. But if you wanted to, on a legacy GPON network, like I said, not even talking XGS PON and 25 gig PON, which improves it dramatically, but you have a granularity of 8 time slots per second. So you could provide latency of 150 microseconds per slot. Now, there's all kinds of overhead. There's rage scanning, new discovery scanning that happens from the OLTs and things like that have an overhead on the administrative overhead on the operation. But yeah, so on the split, you can do most carriers do 32 or 64 splits. So that is across that. So you have eight of these time windows that will be shared across 32 users, for example.
All right. Next question is,
yes, per millisecond, sorry.
Do we think direct monetization is the key, or simply being better than the other guy, sort of competition between the ISPs on this?
That's a really interesting question, because we see very different approaches depending on regions that you're in. So we often get involved in, obviously, gaming being the big market here. It's an obvious market with lots of money. But yeah, for example, North America, there we are seeing more and more products or companies working on products targeted towards gamers for lower latency or better experience, whatever that might mean. And then certainly in the UK, for example, you just got some bragging rights saying we're the best network for gaming, but that's where it tends to end. So there's an interesting split around the world in terms of different approaches on this. As an end user, I would just like it to be better. end of. I don't want to pay more money. But I don't know if anyone else has any thoughts on which one is the better approach.
Well, let me just jump in there though. In which market do you see the best results if they're split like that?
I don't know. I don't have those answers.
Okay.
Sorry.
Well, if one of the markets are not doing anything, just getting bragging rights for doing nothing, I'm sure it's it's not very good. Now, it's a very interesting question. I think, not to sound like a broken record, but simply being better is hard when we cannot quantify what better is, right? And again, back to the same problem. And there are people working on this, Stuart with RPM. We are also able to talk on quality of outcome later, which is also one attempt to standardize a solution where we look at more things as outcomes and probabilities of reaching them. So I think that is a way forward for just being better. But I think as long as we can't do that, I see there is potential for service provider to try to monetize just to get things started, right? And that I think that will be good in the end and better for the end user if we get started now, because it is about getting the operational expertise in rolling out these solutions, right? Which they do not have now.
All right. Question. This is from Erik Taraldsen, working at the Telenor in Norway. So, as working for a fixed wireless access ISP, what should we ask for in the RFQs to improve the user experience?
There's many different ways to look at this. I participate in a lot of these RFPs from the carriers, being Nokia, so I see what comes in, and sometimes I see things I wish would come in. So questions like, what AQM can you support and can you provide? What traffic prioritization capabilities do you support internally or via even partners? Via third parties, can you enable? What quality of service experience facilities do you offer? Those are types of questions that are very rare. They do come up sometimes, but those are the type of questions that I'd love to see in an RFQ or an RFI and RFP, because it shows that the carrier has done their homework and is really thinking about that.
There are some pitfalls here, just to jump in. So for example, when it comes to AQMs, right, it's important to specify what AQMs can actually run in production environment, right? So for example, we see some vendors that can support all kinds of AQMs, very advanced, but they cannot run them in hardware acceleration, and they do not recommend to run without hardware acceleration in production. So in a sense, you get a cool thing you can test in the lab, but you can't deploy it to their end users, right?
It looks good on paper, but in real life, yeah. And we're in that boat here in Nokia. We have devices that support this, and we have devices that will support it in a lab versus and whatnot. So I think the going back, the whole point of commercialization, once we start seeing a drive, then that's going to become more ubiquitous. But you're absolutely right, Magnus. You got to be careful about what do you support and how do you support it. What can you really do with it?
Is there a missing sort of benchmark suite or something for this kind of thing?
I think there's a lot of benchmarks. There's a lot of testing methodologies. There's a lot of standards. I don't want to say competing. They come at it from different angles. They all bring their different value propositions. That's a tough one. I think we might be a bit early in all of this to be able to figure out what is the proper approach. I think in the future that's something that will be easier to do, but at the moment it's still a little bit of the Wild West. There's so many moving parts that we need to improve that it'd be really hard to come up with something that works broadly.
Yeah, so there really are no there are no standardized benchmarks that an ISP can point at and say pass this test and then we'll have
Well,
low latency.
we have some carriers that say this is what's important to me, but then the next one will say no, that's not it for me. It's this. So that's the problem is there's a lot of them and nobody can seem to agree on what is the way to go about it. So yeah, we do have carriers that say you need to be able to pass this test or adhere to this, but it changes every 200 carriers will get 200 different requests. So that's part of the issue.
All right, great. So I think this will be the final question. So what do you think about the statement that it was cheap for ISPs to provide higher speed, but it's expensive to provide lower latency?
I think it's a fair statement, but I think the question was that not the question, but the point was that for the last 20 plus years, we've been in a bandwidth race where the best ISP was the one that offers the highest speed. That doesn't work anymore when we're in the multi-gigabit era where you can get 25 GPON in a residential context. There is not a single use case that validates, that beyond the bragging rights. So I think Peter's right with his question that offering latency is hard because it was always an afterthought. And a lot of the things, as Stuart said, a lot of things you did to increase the speed was very detrimental to the latency. So, we went so far down one path that now to come back, it requires, a forklift upgrade. And for many of these carriers, it's not easy to do. So I don't know if it was that it was cheaper, but the main goal was to increase speed. And that was done at the expense of what is required now to improve latency. So, and
Yeah,
that's not cheap to do.
I think it's I don't think it's cheap necessarily to provide more bandwidth, but I think it's if you rephrase it a bit, so it was a lot easier to create business models for increasing bandwidth than it is for reducing latency, right? So that's the key thing, not necessarily the cost. And it certainly isn't the cost, right? Going from 1 gig to 25 gig is much more expensive than implementing an AQM, but you need to be able to create a business model for it.
Absolutely. All right, I think that concludes our panel. Thank you very much to all of the panelists. And now it's time for a short break. I think we'll make it 8 minutes. So we'll be back at 10 past. Hello, Jose. We're on a break right now, so we'll be back at 10 past.
I was checking my audio.
Very good. It's working.
Just to be sure. Thanks, everyone.
All right, time is 10 past, so we'll jump right into the next panel. So our next panel is on standardization of latency metrics. And standardization of latency metrics, measurement approaches, and solutions. And our panelists are Craig Thomas, Greg Mirsky, Jason Livingood, and Jose Diaz-Martinez. So Craig Thomas is Vice President of Strategic Marketing and Business Development at the Broadband Forum. So Craig has set the strategy for Broadband Forum's transformation from just ensuring that the bands are broad to that they also have low latency. Greg Mirsky is BBF, so Broadband Forum's PEAT project stream lead and standardization technologist at Ericsson, and has extensive experience working on latency measurement standards in the Broadband Forum and the IETF, including latency measurement standards, TWAMP Lite, STAMP, and QED. Jason Livingood leads research, technology, policy, and standards at Comcast. And Jose Diaz-Martinez works for the RDK management team as Director of Broadband Products, where he provides guidance in the design and evolution of RDKB, helping with the adoption of new services and system-on-chip portability. So with that, welcome all of our panelists. And we'll just jump right into the first question. So let's put it to you, Greg and Craig. What standardization efforts related to latency are ongoing in the Broadband Forum? Just to sort of get some context about what kind of work is going on.
Greg, you're the subject matter expert. You go first.
Yes, thank you, Craig. Yes, great question, Bjorn. Thank you. So just to start with their acronyms, PEAT stands for, actually, when we started this project, PEAT came as the champion, even though some people objected to any connotation. So it's a performance experience application testing. And yes, we are concentrating on specifications for measuring and metrics of the performance. And there are several documents that we produced and published, starting with their document on TWAMP Lite, probably by far the most deployed active measurement protocol that we have. Then we proceeded to new protocol that was published by IETF. It's called Simple Two-Way Active Measurement Protocol, STAMP. And it can be deployed in an environment with a TWAMP Lite. So that specification has been published as well. So at this time, there are many other interesting documents that our group is working on. That includes QED. You mentioned that. It's a quality attenuation measurement. QED stands for Quality Experience Delivered. And that's a new methodology to optimize network delivering a better quality of experience to the end user by analyzing the performance of different network segments. Another is that IP capacity measurement, UDP-based tool, and that is combined with a broadband, open broadband work on UDP speed test.
All right, thanks. And Jason, what standardization efforts are ongoing in the IETF?
Well, I mean, most of the IETF work is not a really, I mean, there's some measurement stuff, but I think most of the focus has been on L4S standardization and NQB. And I think, there are already enough things that have come out of either IPPM or the Broadband Forum or other existing tools. Dave mentioned some yesterday with, I think it was iPerf, and some others. It seems to me like there's plenty of possible ways to measure. It's a question of people doing, yes, fluent. It's a question of people actually getting low latency networks deployed, or better AQMs, and then letting people start to measure. I think the reluctance to say that there's one perfect answer right now is, I think there's lots of solutions people have sort of put on the drawing boards or specified, and we're in a phase now where we have to have some actual network deployment, and then people try all these different tests at some level of scale and see what works well and what doesn't, what's understood well by consumers and what isn't, and then sort of adapt and move towards consensus based on that.
Yeah.
So I feel like we're in a very early phase from a measurement standpoint.
That's a great point. Have you thought about what kind of measurements consumers might understand?
Yeah, quite a bit. And I think, I agree quite a bit with Stuart that you have to make it understandable to the layperson, and speaking about like milliseconds and trying to get it low and then telling them about jitter, like, wow, people's eyes just glaze over as an average person. I can't explain that to my mother. I think it's, concepts like round trips per minute, or just calling something like responsiveness, like it's a more responsive network or something like this, or more dynamics, something along those lines. It probably is more understandable to the layperson than like, oh, it's a lower lag, and it's like, well, why shouldn't it be zero lag, or why is there any at all? So it can be very confusing, and I think framing it in a more where it's the number increasing is better, and in a more positive framing probably is better. But I think we'll find out soon. We're planning to do some field trials soon, and we'll play around with some of the messaging to see what resonates.
Cool.
Bjorn, if I may, I just wanted to add to IETF activities in performance measurement. I think yesterday Dave mentioned that it's would be helpful to have constant on-path telemetry information. So, and that is one area that IETF had been working actively for several years now, on-path operational state and telemetry information. There are two methodologies then being defined. One of them is in situ OEM, and another is alternate marking method. So both now are not full. Both of them are now on a standard track, and work is being done now, progressing on applicability of these methods in MPLS environment and IPv6 environment. So that's, in my opinion, very interesting technologies that can allow better visibility into their data flows. One of the challenge with the active measurements is to ensure that test packets experience basically the same network treatment as a data flow. And obviously, by injecting test packets, we are changing the network. And that is problematic in a network that are more resource conscious, like ones that to deliver ultra reliable low latency. That's something that IETF deterministic networking working group is concentrating on, or time-sensitive networking in IEEE. So there are some interesting things that are being defined by IETF, and I believe that they will be coming to other SDOs, and then will be available in the products.
Yeah, thanks. So our last panel was on commercialization and sort of monetization of low latency, and we talked about sort of competition between the ISPs, for instance, and that's sort of a bit in contrast to the standardization efforts, because in the standardization organizations, all the ISPs are sort of piling their money together to find solutions and share them. And if everyone shares the same solutions, then what are they going to compete about? So do you want to discuss a little bit around that topic?
Yeah, I think that's Bjorn, that's a very interesting point, right? Because actually, and this is a bit connected about how we're using open source as well, right? So in my view, right, I'm talking about the CPE software stack, right? So we are going to see foundational services that we are going to have for any CPE, right? It doesn't matter who is going to deliver the CPE at the end, right? And we are going to have added value services, right? And in my view, is for these foundational services, I think it's important that we are going to have the proper foundation in terms. Now, if we are talking about the measurements, in terms of what are the measurements that we are going to expect to measure, right? And connected to basically what Greg was talking, right? Because I think it's really important as well, how we are going to use these measurements, right? In my view, actually, and coming back to what Greg was commenting, right? Because I think it's very important. We have been talking last days about the measurements, but I think that what is key is what we are going to do with these measurements. And I think that the answer for that is telemetry, right? So we need to have the proper telemetry functionality to feed our backend with the right data, right? And not only from one part of the network, from different parts of the network, right? Because it is pretty clear that latency is happening or can happen in any part of the network, okay? And we need to have this kind of, I would say, a standard way to expose telemetry data and to push telemetry data, right? And have the capability to compare, not only to feed in our data lakes with the terabytes of information, basically to have the capability to compare what is going on in different parts of the network and make some smart decisions based on deep learning algorithms or machine learning.
Let me interject there, because I think that's a really, really important point, Jose. Latency measurements, attenuation, etc., is great tool, but unless it is part of the solution that we can automate and regulate, that we recognize there's a problem, whether that's inside intelligence or from the customer point of view, and solve the problem, so that, you know, in a way, it's a part of the jigsaw. Yes, it's a corner of that jigsaw, but unless it's linking to the solutions, which brings in things like automated intelligence and management and SDN, where you're moving sessions dynamically because those measurements and those tools are telling you there's a problem with that link per application, then all it is a tool to say, this is what you're doing, now go and find a solution elsewhere. And that goes, whenever it's latency, that's got to be applicable to the operator's cloud, you know, the first mile, the access, and just as importantly, inside the home, all the way to the device. And unless you're building in tools that maybe are driven by SDN and NFV, service containerization, and in the future a move to metro edge compute as well, then all you're going to do is find a problem that you recognize the problem without an automated solution. And that's where the standards have to come together with latency as a cornerstone to recognize where that self-healing has to come. Now, another point to Bjorn's point, when you're saying, you know, from the last webinar that you did, the last panel you did, it isn't just competition between service providers. Service providers are coming to us at the BBF and saying, well, we want to talk about containerization, not just to be more competitive with other service providers, but to differentiate our services to our existing customers, that we have proof points that says, if you're a gamer, are you willing to spend an extra $2, $3, $4 for a gaming latency measure? Are you, from a SME point of view, willing to pay for an industrial IoT application? Because half the time with latency, it isn't the biggest applications. You know, IoT has to be delivered on time, real time. But it's some of the smallest, bits that being sent across the network. And what you're seeing, and Dion covered this in the last session, is the access network is very quickly multi-service. And when I say multi-service, I mean that it is applicable to industrial IoT, to enterprise, to mobile XOR, as well as residential. As soon as we're talking about 10 gig, 50, 25, and 50 gig network, every service provider I talk to is looking at using that network for multiple customers, not just residential.
So if I understand your points, it's about creating shared ways of measuring and reporting, and that can then drive sort of delivering services that can improve those metrics that everyone agrees on.
Yeah.
Is that the kind of thing you're getting at?
I mean, Domos was part of a demo that we did at Broadband World Forum or Network X last year, where we tried to automate and recognize with latency measurements how you can dynamically do something called subscriber session steering, that you recognize there's a problem, you recognize that latency has fallen down certain parameters, and you move that individual session, not the connection, but that individual session to a different BNG, for example. So this is where you can start using latency tools and measurement into an automated solution as well. Does that make sense?
Yeah. What do you think about this, Jason?
Well, I think that's fine. I mean, in my mind, going back to an earlier point, perhaps, I think there's still this open question of, the statistics that we compare across network types, for example, or network operators. Are those synthetic measures? Are they passive? From observations of actual traffic passing back and forth, and I think we're just still in a very early phase. Of course, unless you start to measure it and report it, people aren't going to be motivated to go do something about it. So it is important, and I think it's good that folks like Ookla are starting to measure it, and it's obviously already in the SAMNOS platform, which is the Measuring Broadband America platform in the US and in other countries, like UK and other places. They have a similar regulator platform. All those things will help because people will end up competing on those things. But I do think that, and some of this came up before, whatever those underlying measurements are, people should be very transparent about how the measurements work, what are the parameters, so that people can really understand them and understand the differences, so that you can say, is this one measure comparable to the other one from another platform? And I think that could be difficult for a while. If we look back to what happened with speed measurement, we can see that lack of transparency around methodology has proven challenging. So you might have some platforms, maybe most notably NDT, which used a single connection to purportedly measure throughput. And then you would have others that would use multiple TCP connections to measure, and they would show dramatically different speeds or capacities, link capacities. And the difference, people for a long time didn't disclose how many connections did they use, what are the file sizes, what's the duration of the test. So I think one of the recommendations to implementers, people that have platforms that are going to start measuring these things and then reporting on them or making them available, is to explain those parameters. How does the test work? What's the duration of the file size? And it's not to say that those things have to be fixed over time. Of course, you can iterate them as you learn, but having transparency about how those things work is important to be able to compare different types of measurements.
Yeah, and I think I guess standardizing the ways in which those measurements are taken, or even just deploying open source solutions that do the same thing in all different places, is a good way to create sort of a consumer confidence in the actual measurements themselves.
Yeah.
So, I think the one challenge, sorry, Greg, really quick, the one challenge we'll eventually have is explaining the measurements once they are more standardized to the end users.
Yeah.
Because for years, I think many network operators and others have trained end users that the solution to all problems is simply more bandwidth. And we're now sort of saying, well, like, it's still really important to have a lot of bandwidth, but there are always also these other attributes that are pretty darn important. So that making that transition will be interesting.
Yeah,
Sorry, Greg, go ahead.
I wanted to continue what Craig was saying, and then try to answer your question, Björn. So, in my opinion, what we are discussing in these seminars is important because that provides information for closing the control loop in a network automation. So basically, to give the information to the system that how the data, what the behavior experience from the network. And yes, as Jason mentioned, there are different ways of doing it: active measurement using synthetic traffic, passive measurements, or what we call now hybrid methods, on-path telemetry. Importance of standardization, in my view, have several benefits. First, when we start discussing these issues, and that's whether we look at quality attenuation or QED, or the new work that have started at IETF, IPPM working group on availability of the service in the packet switch network. We form the dictionary. So we form the dictionary, we map different terminologies so that we can understand as the designers and implementers, and then help their end users to understand that better. And then we produce specifications that enable developers to bring to the market interoperable solutions. So that will help their operators, and they will be ensured that they will not be, paint themselves in a corner and locked with one vendor. So interoperability is one of the main benefits of standardization.
Absolutely, good point.
And then
Greg.
obviously there will be some more efficient implementations. There will be some implementations that provide more accurate measurements. Well, that's a special sauce.
Yeah.
Yeah, I think beyond that, that's a good point. What Greg is talking about, right? Is basically about how we're going to be able to handle different solutions to make measurements, right? But what we should have clear is the measurements that they are going to take, right? And how we are going to use them is a completely different story, right? But as I said before, right, I think that in my view, is important that we have this layer of standard measurements that we are going to be able to take. And other thing that I think is important, and I think we were not commenting, right? Because when we are talking about the speed test, we have to take in account where this data is going, right? And I want to insist that it's quite important that this information, these measurements, can go to the backend of the operator, right? And we have centralized all our telemetry in the CPE to basically push this information into the backend of the operator, right? Because if not, we are going to start having multiple points where we are going to have data, right? And the main goal is that we can cross-correlate the data that we are getting from different parts of the network. I think that to have the speed test only from the CPE can give you an idea, but it's not going to be it's not going to clarify enough what is going on in the network, right? So I think that simple examples that you can have latency issues in one CPE, and you can have latency issues in multiple CPs, right? So you want to know if this is happening in a region, because probably something can happen in the core network, or you want to know if this thing is happening for one specific user, right? And for that, you need to have a massive data lake of information, and you need to have your own way to process all this information to get to some conclusions, right? And from there, you can start doing the diagnosis of what is going on.
Right. So this is about being able to collect the same kind of information from all the different, because a large ISP will have many vendors, and
Correct.
they have to talk the same language. Yeah.
Correct. Yeah.
Yeah, and what Jose said, it's I agree absolutely, and that's why both and Broadband Forum and IETF we pay attention and really have a concentrated effort on working on data models. Primarily, it's Yang data models. So both for controlling the measurements and then exporting the measurement results.
Correct.
Yeah.
Yeah.
And because here you're talking about measurements that are very different from, or not necessarily very different from, but it's a different use case for the results from something like Ookla, which is doing an over-the-top measurement showing the result to the user, maybe selling the result to someone. But this is about the ISP understanding their own network and knowing what solutions, or where there are problems and where there is a return on investment on deploying solutions.
Correct. I think that I completely agree with Greg, right? I think that one of the important parts, and now I'm going to talk a bit more about the CP software stack, right? So one of the parts that, in my point of view, are really important is how we make use of the data model, right? So the more standardized, the better, because this is going to allow to basically improve the portability of different applications that are going to make measurements, right? And actually, they are going to have a predictable layer where they are going to be able to feed in the information, right? Simplifying the whole process, right? When the information is predictable and is standard for everyone, you are going to be able to basically process this information much easier. And it's going to allow you from the CP software stack that you are going to be able to port different speed test applications that at the end, they're going to do their own thing if they want to keep them as a proprietary software, but the results are going to be predictable, and you are going to be able to use the same results, pushing this information using your telemetry to the backend to make your processing in the backend, right? Because I think that it is very important. We talk a lot about measurements, but it's really important to understand what to do with these measurements, right? Yeah. If we are trying to basically carry out proper diagnostics in the network.
All right, thanks. So before we move to questions, I'd like to ask, because we have many panelists and there were many questions in our sort of coordination document before this panel. Are there any questions or topics or points that you'd like to make that I haven't asked about yet?
From my side, so it's Craig here, having trouble with my uplink, so excuse the video. The other thing that we haven't talked about standardization, and I guess an elephant in the room when it comes to latency, is working with the regulators and the government bodies as well. This is a key role of the standards bodies, because I do get phone calls from country regulators as well as regional wide regulators to talk about what can be done with latency for a better management and regulation point of view. And then the other big question, whenever you're talking about latency, is net neutrality, and how can service providers monetize latency without going afoul of some regions' net neutrality requirement. And this is where we're seeing a move that coincides with things like metro edge compute as a way that you can offer different latency packages and monetize it without coming afoul of that net neutrality. But a key role of the standards body is to work with the regulators to let them know what, as Greg was saying, multi-vendor solutions there are out there that can help the regulator measure and monitor his own wider networks requirements from an ISP. So, that's the key role that as the standards bodies have to keep to support the ISP into the wider latency question and monetization of.
Thanks.
It's a good point from Craig. And just one quick comment. I think that the key point of confusion often with regulators and other lay people is they sometimes mistake improved latency with prioritization, meaning somebody's winning and somebody's losing. And I think Stuart addressed that in his kind of kickoff slides. Maybe it was the first day talking about RPM, but I think that's key to explain to regulators that priority is one thing. It's not latency. That when you're improving latency, it's not like you're picking some traffic to win over another type of traffic.
Yeah, I think Stuart was commenting this. That's a very good point, right? Stuart made a very good analysis, right, about things that basically are not working as expected, because we have always the idea to think as humans that the packets behave in the same way, right? It's not like that, right? Basically, right? So things like in 5G network slicing, priority queues, DSCP traffic prioritization sometimes is not having the same result you are expecting they are going to have.
All right, thank you very much. And with that, I think we'll move to the Q&A. Right. First question will be how to create the incentives for the ISPs operators to adopt standard measurement options and most importantly to share their results. Would that come from government policies, monetization incentives, pushes from enterprises or end users? And what can standardization organizations do about that? Who wants to go first?
I'll go first. I think one of the concerns sometimes when you set these measurements firmly in a regulator policy or something like this, and I'll use the example in the US of the upcoming broadband label that's being used. One of the risks is that if you set that standard too early in sort of the maturation process or the deployment process of lower latency networking, you may end up with a bad result and people optimizing to the wrong things. So typically those types of regulators will naturally wait for broader market deployment and consensus to exist before they standardize something, which I think is the right approach.
All right. Any other comments on that?
Well, I mean, just from my point of view, that what's key is that we as an industry have an agreed global standard. What it doesn't help anyone is to have multiple standards doing the same thing. So the liaisons between standards bodies working together with even parallel organizations to ensure that we don't set confusion in the marketplace, that there are differing standards doing 80% of the same thing. So we have to cooperate, liaise, and work closely with other standard bodies. It's an absolute key. If there's one standard, it's easier to adopt.
Absolutely. All right. Thank you very much. And yes, with that, thank you to all the panelists. We'll move to the next talk.
Thanks.
So,
Thank you.
our next talk is from Magnus Olden, who was on the first panel. So you already know him. Magnus, stage is yours.
Thank you. I will be talking about the quality of outcome framework, which is a beginning standard, I must say, that we are just in the infancy of standardizing, which is really about solving a lot of the problems that we have talked about, right? It's taking a lot of inspiration from some of the work in Broadband Forum, a lot of inspiration from the RPM work, and also what Jose just mentioned about also making it useful for network operators. It's kind of our motivations. We've started this work in Domus a couple of years ago, and since I've had multiple of the panelists throughout the days here been part of working on it with Gino and Greg and more. But really, we started with a motivation that we were creating low latency solutions, and we had no idea how to get end users to care about it and internet service providers to care about it. So we started figuring out, hey, there is no good, meaningful way of translating complex network statistics as latency distributions and percentiles and whatnot is to something that is meaningful for the end user. And we kind of sat down and got a couple of goals, and we wanted to create the network quality framework built upon a great already standardized foundation, but that is useful for the end user, people who work for and in network operators, and also applications. So we've called this quality of outcome. So kind of quick agenda. So just setting the stage a bit and the problems we are trying to address, and the design goals we set out. So kind of we have now standardized parts of this in the ITF, or have created the internet draft. And it's split up into two. One part is the design goals, which is really how can we make a network quality framework that is useful for end users, network operators and vendors, and applications. And we have a proposed solution, which is in a separate internet draft. And I'll talk a bit about how that works, and we have an example use case as well. Okay, so I think, this has been a point that's been hammered throughout this entire webinar series, but foundationally, end users consume applications and not networks, right? They do not care, or to a less and less extent of the megabits per second that network can provide. What they fundamentally want is the applications they are using to work as smooth as possible. That is the key thing. And they have been conditioned to look at bandwidth as a proxy for how well applications will work, and that has worked for a long time. But again, like this entire webinar series is about that this doesn't really work well anymore. And because of this, you have all these problems with networks optimized for bandwidth and not latency, and you have a lot of poor application outcome. And I mean, video conferencing calls takes 5 megabits per second, and we're still having problems like all the time. So it shouldn't be like this. Okay, so that's kind of the foundation. Network quality is really complicated, right? And especially when you start talking about outcomes, right? What are application outcomes? Like, just to be clear, what I mean about application outcome is, how smooth is your video conference? How long is the delay between us talking? How many frames per second? What is the resolutions, right? These are the outcomes of applications. Okay, so it is obvious that we should have started looking at this a long time ago. So why haven't we, right? And the simple answer is it's just really complicated, right? First of all, yeah, like the previous panel discussed, just measuring network quality is really challenging. Do you do it under load? Do you do it with varying bandwidth? Do you do it? Which percentiles do you measure? Do you measure packet loss? What about reordering? Like, it's really complicated. And networks are complicated, right? And you're almost always faced with a network where there are multiple owners, right? Multiple operators along the way. And some operators say they own the Wi-Fi, some don't. So that is complex as well. And applications are really complex. You have multiple layers of optimization, both in the transit protocols, but also within the applications themselves, right? And they've been working at that from the beginning online application, they've been working around the network, and they've gotten really good at making techniques to work around the network. And to make it even more complicated, the same application outcome means different things for different people, right? So I do a lot of video conferencing. I know what a good video conferencing call is. My grandma does not, right? And we have can have the same application outcome and a very different experience of it, right? So we have all these complications. Okay, but we don't give up, do we? Right? So again, how can we make a network quality framework that is useful for the applications, the end users, and the operators? So just the design goal, I'll just go through each group of users, right? So for the end user, what do they need, right? They need a network quality metric that is understandable, and the RPM metric from Apple is just a huge stride towards this, right? And it also needs to be mapped to application outcome, right? If a network quality metric does not relate to, how you can't relate it to how applications are, the outcome of application, it doesn't mean anything for the users, because back again, fundamentally, they want better application outcome or perfect application outcome. And from an end user, it's also important that it's honest and objective, right? That's the only way they can trust it and use it and buy better services, because it's honest and objective. Okay, so for the application, so when we started doing this, we started talking with application developers and from the Metas and the Microsofts of the world to small shops, and everyone kind of hates the network, right? It's the bad black box that sometimes fail, and it's really annoying for application developers when the network fails. So we try to figure out what do they want from a better network quality metric. And first thing they said, it needs to be objective, of course, because they need to trust it, all right? And then it needs to be able to can be used to understand if the application will work as intended, right? So they have problem, like from a simplicity point of view, they have a problem now, they set their requirements, hey, I need 5 megabits per second, and sometimes it works, sometimes it doesn't. Then you have, Microsoft can give you quite good requirements for what Microsoft Teams needs, but, smaller developers, shops, they can't, right? So, but they need to be able to set network requirements so that they can understand and measure networks, so that they can be able to understand if their networks will work and if they should change resolution and quality levels the other way. And there's a huge range for application developers, both from the extremely, simple, I just want it to work, and the Teams and Metas of the world who knows every detail about everything, right? So they're also looking for, or different groups within the application developers are looking for both what can be very simple for me and how can I get this perfect, right? So it needs to do both. And also a key thing we got from them was that they want it to be probabilistic, because they don't trust really the network to give anything deterministic. So we saw some requests from like, hey, we need it to be a probability of doing something. Okay, and so from where we started this from was, hey, we put software on home routers, right? And we want to measure network quality end to end and kind of figure out, what will an AQM do for the end user experience? What will, QoS do for an end user experience, right? So this is kind of the heart of where we're coming from. And from network operators and vendors, still needs to be objective and strong mathematical foundations, right? So we see the need, and that's something, we personally felt, this need of composability. So composability essentially means that you can add different steps up, right? So just taking us an example, we put software on the home router for internet service providers, and we monitor the network quality within the LAN side, so typically the Wi-Fi, but also through the access and core network of the service providers. Now, with a speed test or an average latency metric or 99 percentile latency, there is no statistically meaningful way of adding these up, right? It just doesn't work like that, right? So we have no way of saying something about the end-to-end. So this composability, being able to add these together, is key, because that means you can also troubleshoot, try to figure out where the problems are. And we also see the need that any metric needs to be really useful throughout the life cycle, right? It needs to be useful in lab testing and active testing and in monitoring. Okay, so that's a lot of design goals. But we set out anyways, and we made a white paper, which is now an ID, and you can see the IDs here, and we will share these slides. You can go directly through them. But kind of what we figured out was we will not start from the beginning. So TR452 or QED is a problem for standard, which is really a mathematical framework for network quality, where you look at network quality as latency distributions at different load, and you can capture by looking at the distributions, and you can say packet loss is actually infinite latency. You can actually capture like all the different features of latency, from jitter to peaks to packet loss within a single metric. And it is composable, because with distributions, you can actually do convolutions. You can add them up, or you can do deconvolution if you do some mathematical assumptions. And the framework allows for this to be useful in active testing and in monitoring and lab testing. And you can describe really, really complex network requirements in it. So this framework was written for service provider or network operators, right? It's perfect for them. It helps them troubleshoot their network if you get past the complexity. But it's kind of not aimed at end users and applications. So, but we want to start there. And we want to find the middle ground between quality of experience metrics, right? MOS scores, MPS, GMOS is something like, there's plenty, like none of them really maps to network perfectly. We know that, and subjective and highly unreliable. On the other side, you have this quality of service metrics like bandwidth, latency, with all its forms, and packet loss, which is really complicated and it's unrelatable. I mean, even for me, who works on network performance, how good is 35 milliseconds latency of jitter? Like it doesn't really mean anything even to me, right? So we try to find this middle ground, which we call quality of outcome, and it's essentially looking at what is the probability of reaching network requirements. And you can set network requirements for whatever, right? So for example, a video conference. So kind of looking at a network as from an end-to-end point of view, and say, what is the likelihood of perfect video conference for this network, which can be both objective and pretty relatable, and I think it's pretty understandable for a lot of end users. So kind of, we don't have time to go into a lot of details here, but it's all in the ID. But essentially, the framework is not much on top of the TR452 network requirement, other than that you use latency distribution as the foundation. And you don't really take a say in how you get that latency distribution, but you should know how you do it, so we can evaluate what kind of confidence we can say things in. And then we can set up application requirements, SLAs, or whatever you call it, any network requirement. And you describe them as an example, video conference needs 5 megabits per second, but it also needs 90% of its packet throughout within 100 milliseconds and 99 within 150. And then we also ask them to set a point of uselessness. For example, if the 10% of the packet or 90th percentile latency is more than 400 milliseconds, or the 99th percentile latency is more than 500 milliseconds, we know it's not going to work at all. And the key thing we get here is this distance measure between perfect and useless. And with some assumptions on linearity, we can actually call this a probability. And that's how we go from simple or complex network requirement, and monitoring latency distributions on my network to this probabilities of reaching different network requirements. And kind of key part here is that it's useful both top down. You can look at what is the end-to-end quality of this network, or you can look at it bottom up. How does the Wi-Fi link, how does the cable link, how does the core link contribute to the network degradation? And that's kind of the key framework. There are plenty of details that you can read more on, but just a showcase, right? So just to show kind of what you can do. So L4S had a plug fest, and we tried to figure out, it had really good results, but there was really like network statistics, right? So here's like a use case where we show what the quality of outcome difference for conferencing and gaming and streaming and VR is for typical households, right? So kind of we took kind of key metric from the IETF L4S plug fest was, they reduced downstream 99.9 percentile working latency from 96 to 7 or 8 milliseconds, right? But what does that mean, right? Back to this. So we kind of took the before and after from the Flugfest, like what was the latency before and after. And then we took some household from some Domus employees, and kind of, because these results were just from optimizing the access and core network, but most people use it end to end. So we added this Wi-Fi link from typical Domus household. And then we used this composability feature of the framework and add them together, so we get this end-to-end measure. And then we use Domus has some standard requirements for conferencing and gaming and AR, VR, and streaming. So kind of what does that mean, right? So here are the results, right? So for four of the worst devices, admittedly, of the Domus employees, what does that mean? These L4S improvements, right? So the results are here. It's even a GIF showing before and after if you wait a bit. But essentially, depending on the device and the network conditions, it went from 0% probability of interactive VR to 15, or it went from 76% probability of a perfect video conference to a 93% probability. This is kind of, I just want to showcase like some of the features of this composability, right? So you can add them up. You can take any results and just calculate any network quality requirements. Right? So yeah, that was me. Thank you for listening. And if you're interested, please get in touch and help contribute and critique.
Thank you very much, Magnus. We'll move to the Q&A, and the first question is, why establish perfection as a target? Users will be happy with much less than perfection, and subjective tests illustrates this phenomena.
No, it's a very good question, right? Because the answer is kind of simple, because we have no meaningful way of putting the point differently. Like users are, okay with less than perfect, but where that point is depends on the end user. So if we want to do this objectively, right, there is no other good place of putting it. So I totally get the point, right? And it's a good point, but I don't see any other way.
All right. And Dave is asking, have you tested Cake through this tool yet?
We will. When this webinar is finished, I have some more time.
Okay, cool. And where was L4S enabled for this quality of outcome testing you showed in your last slide? On every hop of the data path, home network, access network, metro network, etc.
Yeah, it's not my data, but it's from the L4S plug fest from August, I believe. I think it's from the access network into the core network. If Jason is still online, he can jump in and answer.
Yeah, I think it was from the first one in July of last year at Philadelphia. Then we had a
All right.
second one in London, I think.
And it was from the over the access and core network, right?
Yeah, yeah, and it was tested on both. All three network types. I think there was DOCSIS, 5G, and Wi-Fi.
Nice.
Okay. Thank you very much. That was our final question. So thanks again, Magnus, for your talk. And now it's just up to me to conclude the webinar. All of our talks and panels are done. And I'd like to once again thank all of our speakers and also all of you for attending and making this a great event. And having said that, I want to sort of make a speech. So let me just share my screen. I want to have a background. Okay, so my main takeaway from this whole webinar series is that Gavin was absolutely spot on in his keynote on Monday. As an industry, we can keep doing what we've been doing for the last 50 years, building more bandwidth, but more bandwidth no longer makes a significant difference for consumers, which is why the time has come to tackle the latency problem. That's going to take new business models and new ways of doing things. In other words, it's going to take innovation. And it's really very encouraging to see that ISPs and their vendors are getting ready to execute on this. But let's not pretend that this will be sort of a quick and easy job. It's a monumental challenge. To change the narrative of more bandwidth is what you need in the minds of vendors, ISP decision makers, and most importantly, consumers. But a monumental challenge can also be a giant opportunity. Google, Apple, Netflix, all the big tech companies have shown that there is a lot of value in delivering great online services to consumers. And a lot of that value is still untapped because it's virtually impossible to buy a low and stable latency internet service today. So to conclude, the internet can be a lot better than it is today, but it will take a major shift in business practices for all of the companies that are building internet infrastructure. And then finally, I want to encourage those of you working on applications, operating systems, and internet platforms to help ISPs and their vendors pull in the right direction. Improving latency is a win-win situation. With lower latency, applications can deliver better experiences with less frustration and more engaging interactions. And you can help, and some of you already are, educate consumers that latency is what they should care about when buying internet service or a Wi-Fi router and laptops and mobile phones. We all want better internet. We know what the problems are, and we even know what the solutions are. So we just need to get it done. So let's get it done. And I wanted to finish with this GIF. Let's go. So thank you everyone for attending. This is the end of our webinar series, and I hope to see you again next time.
Thank you, Bjorn. Thank you, Magnus. Take care.
Thanks, Craig.